Hey Ms. Jensen, today I am teaching the intermediate value theorem. So I will start off with defining it. So, if f is continuous on the closed interval a to b, and k is any number between f of a and f of b, then there is at least one number c in the closed interval a to b such that f of c equals k. So this sounds very confusing when put into words, but if you visualize it, it is understood much easier. So basically here is your function in the interval a to b. So what it is saying is the function, there's a y value for every point between this. So what is it between these two? So what it's saying, so if you evaluate the function at point C, you will be given the value, you will find the point K, which is a y value between f of A and f of B. So f of C will equal K, and also, although this graph only has one value of C, you can have, if the graph did something like this, you could have, so that's not really a function, but you could have multiple C value. You could have multiple C's that equal K. But in this case, it's only one, and it is located right here. So now I will be doing a practice problem where you are given a real function and not just a hypothetical situation. So the problem states, use intermediate value theorem to show the polynomial function f of x equals x to the fifth plus 3x squared plus 5 has a 0 on the interval of -3 to 0. So this is done with 5 steps, which some of them are very simple and seem kind of unneeded, but some of them are very necessary. So what we are doing is, so first we have to state pretty much a given. It's fairly monotonous, but so the first step is you have to state f of x is continuous on the interval -3 to 0, which is given in the problem there. The second step is actually two parts. So you're going to plug in each of the two numbers on the interval, so the two extremes of the domain, into your function. So you're going to have f of -3, so you plug that in, equals -243 plus 27 plus 5, so that's -211, and then you're going to have f of 0, which equals 0 plus 0 plus 5, so equals 5. So you do that, and you get the two, what the functions equal at those two spots. So you get your y value when you plug in your x value. So then, so that's 2a and 2b. Then in your third step, you have to state f of c equals 0. So that's just saying when you plug in your value of c, you have y equals 0, so that's a 0. So that's like also a pretty easy, simplistic step. So now you state why it's a 0, why you know there is a 0 on the interval. You're not finding exactly where the 0 is, you're just stating how you know there is. And you know that because plugged in, you know there's a 0 between -3 and 0 because f evaluated -3 is to -211, which is less than 0, which is less than 5, which is f evaluated at 0. So you know there's a 0 somewhere between -3 and 0. So that's a pretty simple, so yeah, that's pretty easy. So then you just have one more super simple step. You just have a short sentence and you put, by intermediate value theorem, which is abbreviated to IVT, there exists a 0 in the closed interval of -3 to 0. So those are the 5 steps on showing that. That's about all I have. Thank you for watching, Ms. Jensen. And yeah, hopefully I don't fail.